A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It is composed of semiconductor material, usually with at least 3 terminals for connection to an external circuit. A voltage or current applied to one pair of the transistor's terminals controls the current through another pair of terminals. Because the controlled power can be higher than the controlling power, a transistor can amplify a signal. Today, some transistors are packaged individually, but many more are found embedded in integrated circuits. The transistor is the fundamental building block of modern electronic devices and is ubiquitous in modern electronic systems. Julius Edgar Lilienfeld patented a field effect transistor in 1926, but it was not possible to actually construct a working device at that time. The first practically implemented device was a point contact transistor invented in 1947 by American physicists John Bardeen, Walter Brattain, and William Shockley. The transistor revolutionized the field of electronics and paved the way for smaller and cheaper radios, calculators, and computers, among other things. The transistor is on the list of IEEE milestones in electronics, and Bardeen, Brattain, and Shockley shared the 1956 Nobel Prize in Physics for their achievement. Most transistors are made from very pure silicon or germanium, but certain other semiconductor materials can also be used. A transistor may have only one kind of charge carrier, in a field effect transistor, or may have 2 kinds of charge carriers in bipolar junction transistor devices. Compared with the vacuum tube, transistors are generally smaller and require less power to operate. Certain vacuum tubes have advantages over transistors at very high operating frequencies or high operating voltages. Many types of transistors are made to standardized specifications by multiple manufacturers. The transistor is the key active component in practically all modern electronics. Many consider it to be one of the greatest inventions of the 20th century. Its importance in today's society rests on its ability to be mass-produced using a highly automated process that achieves astonishingly low per-transistor costs. The invention of the first transistor at Bell Labs was named an IEEE milestone in 2009. The essential usefulness of a transistor comes from its ability to use a small signal applied between one pair of its terminals to control a much larger signal at another pair of terminals. This property is called gain. It can produce a stronger output signal, a voltage or current, which is proportional to a weaker input signal, that is, it can act as an amplifier. Alternatively, the transistor can be used to turn current on or off in a circuit as an electrically controlled switch, where the amount of current is determined by other circuit elements. There are 2 types of transistors, which have slight differences in how they are used in a circuit. A bipolar transistor has terminals labeled base, collector, and emitter. A small current at the base terminal can control or switch a much larger current between the collector and emitter terminals. For a field effect transistor, the terminals are labeled gate, source, and drain, and a voltage at the gate can control a current between source and drain. The key advantages that have allowed transistors to replace vacuum tubes in most applications are: no cathode heater, reducing power consumption, eliminating delay as tube heaters warm up, and immune from cathode poisoning and depletion. Very small size and weight, reducing equipment size. Large numbers of extremely small transistors can be manufactured as a single integrated circuit. Low operating voltages compatible with batteries of only a few cells. Circuits with greater energy efficiency are usually possible. For low-power applications, in particular, energy consumption can be very much less than for tubes. Complementary devices available, providing design flexibility including complementary symmetry circuits, not possible with vacuum tubes. Very low sensitivity to mechanical shock and vibration, providing physical ruggedness and virtually eliminating shock-induced spurious signals. Not susceptible to breakage of a glass envelope, leakage, outgassing, and other physical damage.